In this video, we are going to go over some general definitions for factoring polynomials and also talk about our first method, which is factoring out the greatest common factor, or the GCF. You will be taking your notes in your book of factoring, starting on page 1. We're just going to define what factoring polynomials means. It involves breaking up a polynomial into simpler terms, the factors, such that when the terms are multiplied, they equal the original polynomial. In the past, we have likened this to doing 12 and writing it as 3 times 4. I am writing my polynomials as a product, multiplication, of 2 other polynomials. So this is factoring using numbers. We're going to be factoring using polynomials. Essentially, we are just undoing our distribution or our box or our FOIL. We're undoing multiplication. Let's review our classification vocabulary for our polynomials. Our constant term has no variable. Linear term has an exponent of 1. Quadratic term has an exponent of 2. And cubic term has an exponent of 3. Monomials have 1 term. Binomials have 2 terms. Trinomials have 3 terms. Now, 2 definitions that we haven't spent a lot of time on: standard form and prime. Standard form is an arrangement of terms in a polynomial where the highest degree, the highest exponent, is first and is followed by the other terms in order of decreasing powers. So let's look at an example here. If I have 6x squared plus 3x minus 8 minus x cubed. This is not in standard form because my highest degree is not first. So to rewrite this in standard form, I would put the negative x cubed first, then the x squared because it's the next, then the 3x, then the minus 8. So this is my cubic term, quadratic term, linear term, constant term. This is in standard form. Now, a polynomial is prime if it cannot be factored into the product of 2 polynomials using integer values. So in other words, the only factors of the polynomial are 1 in itself. This is the same concept as our prime numbers 2, 3, 5, 7, 11. Those are prime because they're divisible only by 1 in themselves. A polynomial is prime if it cannot be broken up into smaller factors. Okay, let's take a look at our first method for factoring, which is the greatest common factor. We have already taken some notes on this, but we're going to make it formal in our booklet here. First, defining the greatest common factor. It is the largest monomial, 1 term, that is a factor of each term of the polynomial. So remember, that means it divides evenly into. So when you divide, you get no remainder. To find your greatest common factor, first looking at your coefficients, so looking at the numbers, list the factors of each number, and choose the one that is largest that they have in common. For the variables that are common, you're going to choose the smallest exponents. Now, our steps, and let's actually start by talking about when do we use this method. That's always important for us. You are always going to look for your greatest common factor first. So as we learn each new factoring method, we're going to talk about when do we use this. In this case, always. Always check for the greatest common factor first. Okay, so first we're going to find our GCF. Then we're going to divide all terms by the GCF. Remember, when you divide with like bases, subtract the exponents. Then we will write it in factored form, which will mean it'll be a monomial times a polynomial. And then simply distribute to check your work. Again, this last step I typically do in my head. I don't typically write that step down. All right, we're going to do a couple of examples together, and then you'll do a couple of examples on your own. We're going to start with example 1. So 3y cubed plus 3y. Hopefully we can all fairly quickly say my GCF there is 3y. 3 and 3 is common, y is common, smallest exponent of 1. So when I write this in factored form, it's going to be 3y times something. And to figure out the something, I'm going to just simply divide each term. So 3y cubed divided by 3y. 3 divided by 3 is 1. Y cubed divided by y is y squared. 3 minus 1 is 2. Plus 3y divided by 3y. 3 divided by 3 is 1. Y divided by y is 1. So that is my answer. Now, it is important to note, I don't actually need this one. If that one is not there, it's okay. But this second one, I have to have it. Otherwise, there's nothing there holding my spot. So be very careful with that. Okay, let's take a look at example 2. So my coefficients, 4, 16, and 12. If you need to list the factors, go ahead and do so. But I can very quickly see 4 is my common factor. It's my smallest number and goes into the others. Then x to the fourth, x cubed, and x. The x is common. And the smallest exponent, again, of 1. So I'm going to have 4x times something. And to figure out that something, I divide each term by 4x. So 4 divided by 4 is 1. X to the fourth divided by x is x cubed. Minus 16 divided by 4 is 4. X cubed divided by x is x squared. Plus 12 divided by 4 is 3. X divided by x is 1. So there's my answer. Last but not least, for the video anyway, example 3. You're going to do 4 and 5 on your own. I have 9, 12, and 18. Again, list the factors if you need to, but I can see that 3 is going to be my greatest common factor there. And then I've got x to the fourth, x cubed, and x squared, so x is common. So it's going to be an x squared, because that's my lowest exponent. Notice the y is not common. My first term does not have a y. The other thing I want to point out here, my leading coefficient, my first term is negative, so I'm actually going to pull out a negative 3x squared. So negative 3x squared, and to figure out what goes in the parentheses, I am going to divide each term by negative 3x squared. Notice that's going to change all my signs. So I'm going to have negative 9 divided by negative 3 is a positive 3. X to the fourth divided by x squared is x squared. 4 minus 2 is 2. 12 divided by negative 3 is negative 4. X cubed divided by x squared is x to the first. And then just y. And then negative 18 divided by negative 3 is a positive 6. X squared divided by x squared is 1. And then y squared. So that is my final answer there. Again, you are going to try number 4 and 5, and then raise your hand. I'll come check them, and we'll correct them as we need to.